Okay, so we looked at simplifying some expressions on the previous video using addition and subtraction. Now we're going to look at how it's different if we're using multiplication and division. So what do we mean when we're simplifying expressions? It means we're trying to make the expression easier to work with, but we're not changing its value. That's the key. So if you have these two expressions here, so we've got 300 over 500, and say you put that into your calculator, that will give you a decimal of 0.6. Now, if you did 3 over 5 in your calculator, that's also going to give you 0.6. But this one is much smaller and nicer to work with. So if you're simplifying, you'd want to use that smaller one. So if we have a big algebraic term like this, we can omit the multiplication. And this is what we do in algebra because we use multiplication a lot. So we can reduce things by putting these numbers and letters together to make it smaller and nicer to work with. So we can keep the 3 there. And we've got two a's, so that's going to give us a squared. And we've got three b's multiplying each other, so that's going to give us b cubed. Let's look at just one more. What about this one? So we've got the minus 2 still. Like I said, we can get rid of the multiplication signs, but they are still there. So 2 minus 2c. And we've got two d's, so it's going to be d squared. And we've got two e's, so it's going to be e squared. Now the key is that both of these sides of the equations are still have the same value. We've just made it a little bit nicer to work with. Now, when we are simplifying expressions, we need to be aware of the commutative property. So this is where if we switch the order of operations, this is not going to have an effect on the value. You might be aware intuitively that multiplication has this property. So with multiplication, as you can see, 3 times 7, that's 21. And if we switch the order to 7 times 3, that doesn't change anything because 7 times 3 is still 21. So in multiplication, the order does not matter. We can switch things up and we won't affect the value. But what about with division? So 3 divided by 6, that's 0.5. But if we switch that up to 6 divided by 3, if we swap them around, 6 divided by 3 is 2. So that does affect the value. So division does not have the commutative property. We can't switch them around to keep the value the same. So the key takeaway is we can switch the order of multiplication without affecting its value. So let's bring it back to simplifying expressions. So if we want to make this expression simpler and easier to work with, first we can write out what this actually means. We're going to expand this expression. So when letters and numbers next to each other, that means multiplication is going on. So this means we have 4 times a times b times 2a. And 2a is just 2 times a. Now, because multiplication has that commutative property, we can mix up the order of these letters and numbers, and we're not going to affect the value. So let's put the numbers together, 4 times 2, and let's put the same letters together, a times a, and then b is the last one out there on its own. Now we can keep simplifying this. 4 times 2, that's 8. And a times a, that's a squared. Just leave the multiplication here for now. And times b. And now we have numbers and all the variables together. We can get rid of these multiplication signs. They are still there, but we're just cleaning things up and making it simpler for ourselves. So we only do this with multiplication, where we can get rid of the operation, but it's still there if we have numbers and letters next to each other.